This is Anurag Jain. I am a developer advocate and product manager at Thales Group. This is the last part, the third part of the series where we are installing and configuring Thales Data Protection Gateway. And in this particular part, we are going to introduce the Ansible collection and the playbook that we are going to use for deploying all the components that we have done so far manually, as well as configure CipherTrust Manager for data protection, gateway protection, and access policies. All of this we are going to do through thalesgroup.cyphertrust collection. There is a separate video where I have shown how you can install this collection on your Ansible controller node. So this is the use case that we have been following. So we have taken a micro Kubernetes system on Ubuntu, and we deployed through the deployment.yaml file. We deployed the STRAPI backend uh, application as well as the React front-end application. And we also saw in another video how we can configure CipherTrust Manager for the keys and policies that will allow DPG to act accordingly and protect the data which is traveling on JSON. In this, we are doing to perform all those actions using Ansible collection. So the process of setting up the protection policies and access policies, everything through the Ansible collection itself. Uh, okay, before we go into it, so this is the URL. This is the GitHub URL where the playbook is being hosted for this purpose. I will put all the links and everything as part of the video description so you can follow along. I'm doing bit more things, than what I'm going to demo today. But this particular playbook is capable of not only configuring CipherTrust Manager, but also work with your Kubernetes cluster through a third-party collection, which is kubernetes.co.kts. So I will not go through this complete file. You can check this on later, but I'm going to show you how we are going to perform all the operations that we did in the last video in terms of creating the policies and keys and everything through Ansible. Okay, so I have cloned the repository, and this is the place, or this is the location where my playbook and the variables file is present. So I have trimmed down the playbook a little. So if you look at the GitHub URL, so I'm doing some cleanup activities. I'm killing the existing namespace. I'm fetching all those existing assets on CipherTrust Manager and deleting them. But in this particular trimmed down version, this is exactly same, but I've just removed some of the cleanup operations, and I'm running the process of configuring the CipherTrust Manager directly. I'm also not in this particular YAML. I'm not deploying DPG. I'm rather stopping at a point where my deployment file is generated. I'm using Jinja template to populate some of the information. So I'm going to do operations till then. So a quick overview. So these are some of the tasks that we are going to run. So I'm if DPG HIPAA namespace is already present, I'm deleting it. I'm performing operations like creating the key which will be used for the cryptographic operations by DPG. So I'm using an AES 256 kind of key in this. And then the 9006 interface. So if it already exists, it will be ignored. We know that 9006 is already configured on our CipherTrust Manager. So the playbook will skip this task. Then we are doing things like creating the character set, creating the protection policy. As we saw last time. So I'm still using the same algorithm SHA-1 with the same tweak and the key which was created in the task above. And the algorithm that I'm using is a format preserving algorithm. I'm also creating user sets. So I'm creating a user set with patients, with users, patient 1, 2, 3, 4, 5, and another user set which is practitioners, and that has the user nurse. Finally, I'm creating the access policy with the above information, with the information like Ciphertext is the default reveal type, and for the users which are in patients group, they will see plain text, and in the practitioners, they will see the ciphertext. Uh, then finally, I'm creating the DPG policy where all the REST API endpoints and the fields that need to be protected. So I'm configuring in the exact same way. API patients was our endpoint. The fields that we were trying to protect were data.name, and the operation was protect with the given protection policy, then surname, contact number, and all the other fields that we want to protect here. Finally, the reveal part. So this is the get operation on the same API endpoint. And as you remember from the last time, the API response is of type array. So data is the high level field which contains an array of attributes, and within attributes, the fields are there which are protected. So in this, I'm performing or configuring the reveal operation with the given access policy. With all this information, we are finally creating the client. So client requires the DPG policy as input. And then there is a Jinja file which is present. I created a Jinja formatted file for deployment, for Kubernetes deployment. It's going to replace some of the variables with the output that we received above. So it will pull the information like registration token. It will put a destination URL, all those things. It will get or fetch from the above, and it is going to put that in the deployment file. This playbook leverages a variables file. So let's quickly go to the wheres file as well. This contains the information like, okay, this is our CipherTrust Manager IP address. This is the username and password. This is my Kubernetes server IP, which in this case, this present machine itself. Then the key name, character set name, protection policy, and access policy name, the user set names, all those variables I have defined here. You would also need to tell the CA ID or the certificate authority ID. So this is something which I pulled directly from CipherTrust Manager. So if you log into CipherTrust Manager and you go to CA local, you will see that this is the CA ID that I have used in my example. Okay, with this, I should be able to run the playbook with simple Ansible playbook.yaml, and I'm running in a verbose mode. So, as defined in the script, it has first tried to delete the namespace. I'm just going to skip this, and it's now configuring other things like keys and policies and the other things. And finally, once the policy is created, it will get the registration token which is required by DPG to perform or to work with CipherTrust Manager. So the output that I gave was this file. So yeah, so this particular file has been generated by Ansible. So this, if you remember, this is the same deployment file that we created earlier. It's just that the registration token now is the new one, is the application that we just registered. So if I go back to my CipherTrust Manager instance, I should be able to see two applications and application data protection, and this is the one which we just created. So a HIPAA client profile demo, it should have similar kind of policies. It should have all the required get and post API tokens, and the protection policies created. So I gave demo in front of each of these variable names, so you can see all these assets have now been configured on now have been configured for the Kubernetes environment. And if you want to follow this exact playbook, this also takes this particular output file. It create the required namespace, and it deploys all the applications and data protection gateway using Kubernetes core K8s module, which is nothing. It's just like kubectl apply -f, and this is the file name. So this is it. You can use Ansible if you're already using Ansible to deploy your services, then you can add the tasks that are relevant for talking to CipherTrust Manager and doing the configuration. Or if you are creating a new one, you can leverage some of this information in deploying your own applications on Kubernetes, as well as configuring CipherTrust Manager so that data protection gateway is correctly configured for your application. So I hope you liked it. This is the last part of the series where we used Ansible collection to deploy data protection gateway along with your own applications on a Kubernetes cluster. So in my case, it was a Ubuntu Kubernetes cluster, and get the output where all your apps are running and the sensitive information is protected. I hope you enjoyed it, and if you did, please like and share the video and subscribe to our channel, and stay tuned for such more content. Thank you again.